Hey guys, so today we're going to be doing this slide here, and I think it's slide 34 on your notes. I could have the number wrong because I kind of add stuff and, you know, change things as we go along. But hey, it's after these two slides, which you were supposed to do yesterday. This one on binary fission, which is cells like, bacterial cells replicating their DNA, splitting it into two pieces, and then dividing down the center. So this is a form of asexual reproduction. That is reproduction without a mate. Like, they don't have to find anything. And they can do this about every 20 minutes for about as fast as they can do it, but every 30 minutes kind of on average. So bacteria can actually double their population every 30 minutes. Quite quickly they can spread pretty rapidly in your body or just in the right conditions anywhere. After that, you were supposed to watch a slide on conjunction and also watch the video on conjunction as well. And then when you were all done with that on Classroom, your assignment had this other linked video right here, this binary fission video, which was on Classroom right here, that you also should have watched. And that just like animated the process, showed you how things are replicated and divided during binary fission. So that's kind of how bacteria reproduce. The why, binary fission, asexual reproduction, the why, guys, it's fast, it's easy, it's cheap. You don't have to take a date out or anything like that or buy them dinner or anything. You want to make babies? Boom, hey, divide your DNA, make a baby, right? So things are going well. Bacteria do this. If conditions are right, they just reproduce like crazy through asexual reproduction. So why the need for conjunction? Why the need to go through sexual reproduction? It's simple. If conditions aren't good, if the pond's drying up, if you are exposing them to an antibiotic, if you're trying to kill them, they will start to go through conjunction so they can swap pieces of DNA and therefore increase their genetic diversity, making all the little bacteria cells different in the hopes that some of that difference will allow some of them to survive. And when those some survive, they can reproduce and form the next generation. And that is the key for the superbugs kind of stuff that we were talking about a few days ago. The genetic differences allow these pathogens, these superbugs, to kind of become more numerous. We kill off all the weak ones first, like my note said earlier, but the strong ones, they stick around, and if you stop taking your medicine too early or something like that, those strong ones survive, they reproduce, they make the next generation, and then you have just made a bacteria that's stronger than all the bacteria that were there before. Evolution. They've changed. And we see this happening every day, all the time. Hotbeds for superbugs are hospitals because of the antibiotic use there and the drugs that are used and the patients bringing that bacteria in. So this is kind of wrapping up the bacteria stuff, and we're going to get into protists. Now, I'm going to do this a little bit different way. It's a little bit interactive for you. So on Classroom, there's a link to a Google Jamboard, and it looks like this. It's exactly like what you did before. And what I would like you to do is just add one thing. And I don't really care what that thing is. And this just goes through all the bacterial stuff that we've talked about before. So how do bacteria get energy? If you want to add something in there, type it in, write it in with your finger, whatever, go for it. Write it so that we can actually get other people's writing in there. So you may want to pinch your screen or hit the zoom button to get in here nice and close before you start writing, because there's going to be everybody in your class adding something to this jam. So it could be something about how they reproduce. We just talked about that. That might be fresh in your mind. You might want to add something about that too. Also, are they friend or foe? You can talk about how some of them are infectious and maybe give me examples of which ones are. And maybe you give me examples of what they do that's good for people, because there was a lot of things that bacteria did that were good. Some of you guys didn't do that reading out of the textbook. I know, because I saw some of your answers. And a lot of you guys did, and you found some amazing things bacteria do for us. And the good things that they do for human beings, why we want them around. Like we were just talking about hospitals. They make insulin for diabetics. What? Bacteria make insulin for people? Sure do. So unless you read that reading, you probably wouldn't know that. So I want you to fill out something, add something to this Jamboard. By the end of the day, kind of check back as other people have added stuff and look at what they've added. Feel free to like change it if they have the wrong information. Feel free to update it if they have wrong stuff. But at the end of the day, take what's in this jam, go back to your notes, and type these things in here. So add that information in. You could have both screens open at the same time. You can flip back and forth. You can put them side by side, however you want to do it. But then put them in your notes so you have it. After that, you're done. Okay. We are going to get into, I think I'm going to kind of skip this. You're welcome to do it, but we're going to go jump into protists starting after that. So what are protists, etc. That's what you got for today. Doing a jam, editing your notes, you're good to go.